Well, yes, certainly. And we kind of keep our eye on our data, and this is where the research is accumulating. Let me just mention a few of them to you, Jerry. We brought up dinosaurs a few minutes ago, said to have died out 65 million years ago. You know, in recent years, what's happening with dinosaur bones, they're being opened up, they're being cut open. This hadn't been done before. And inside dinosaur bones, we are finding material that looks very fresh and recent. We're finding tissue, we're finding red blood cells. I've seen some of that data and been in the lab where it even there's an odor to it. And all sides would agree, look, if these things are really millions of years old, they've got to be completely dried out. Any DNA that was in there must be broken down. And yet we're finding freshness in these bones, which kind of shows that things may not be as old as they say. Not that you can put a date on it, but it's challenging the ancient Earth view. Uh, in the in another area in the Grand Canyon, when we look at those rock layers, there's evidence that those layers did not form very slowly, millimeter by millimeter, but that the layers form rapidly, and then it was eroded rapidly as well. In the Grand Canyon, we can find, for instance, we have it's all sedimentary layers that were laid down in water, but these layers in many places are warped, they're bent, they're twisted. And we look very closely at these curved sedimentary layers, and they don't show any breakage like it was solid rock that was fractured by earthquakes. And there would be chemical changes as well as if you would rapidly bend these layers or do that slowly over time. The way that these bended layers are showing is that it happened while those rock layers were still in a plastic, non solid state. So it shows, again, evidence for rapid deposition and then a rapid bending as well while the canyon was forming and not a slow motion event. You know, another thing that we find in these sedimentary layers, there are what are called polystrate trees. We can find large tree trunks, long ones that kind of impede through several different layers of rock. And there they are, 10, 20, 30 feet in length vertically. If the Grand Canyon layers were forming very slowly, they talk about shallow seas where the sand was coming in and forming the layers. If somehow a tree got in there, if it's going to take a long time, the tree would deteriorate, it would fall over, it would disintegrate, it might get struck by lightning. But instead, it looks like these long trees were rapidly buried, which again is evidence for a rapid formation of the Grand Canyon. Again, I don't think that the Grand Canyon is a monument to time. I think it's a monument to the flood event. And you know, the thing is, that's a special place there in Arizona. I know you have some smaller canyons in Alabama. We got a few in Indiana, but at least up here in the north, in the Midwest, the ice came through the ice age after the flood and kind of leveled all the land, but it didn't reach Arizona. And so that's where we still have a fresh view of what the flood did at that time. Mention one other area since you were asking about evidence. And that's kind of in this book that you held up a little while ago, Thousands, Not Billions. A few years ago, a few of us thought, let's take a fresh look at some of these age assumptions. And there's a lot in that book. But one thing that we got to looking at, Jerry, was carbon 14. Now, that's kind of a common name, and some people say that sounds evolutionary. Carbon 14 is a radioactive isotope. It turns into nitrogen 14, half life of 5,700 years. So it forms in the upper atmosphere, floats down to the ground, gets taken up by trees. It's carbon, and then it slowly transforms away because it's radioactive. Carbon 14. Well, if you have a fresh tree or a piece of wood or even part of a desk, it'll have some carbon 14 in it because wood, trees, vegetation, they suck up carbon 14. However, if you have a log that's been long buried, or maybe a very old fence post, its carbon 14 should be depleted, should have gone away. So anyway, in this research project, as described in that book, we thought we would look at samples that are said to be so old that they should not have any carbon 14 left in them. One thing we looked at was coal. Now, coal is made out of carbon, said to be from the Carboniferous period, hundreds of millions of years ago. And so we gathered coal samples. We didn't do the experiments ourselves. We instead went to top state-of-the-art laboratories. And we said, sir, we would like to pay you to analyze these samples for carbon 14. Well, the technician said, are you guys out of your minds? Don't you know that coal is old? You're going to waste your money. It cannot have any carbon 14 in it. But we said it's a research project going on, and so they did this for us. In fact, we went to several different labs. We looked at many different coal samples, and in every coal sample was found carbon 14, to the great surprise of the laboratories. And they said, well, maybe that coal's been contaminated, and there's all kinds of excuses for that. You can analyze the data that they came up with and crunch it down, and you can make the case that the coal, whether it's in Alabama or Ohio, wherever, is about 4,500 years old. Well, that takes you back to 2,500 BC, which is the time of the flood. It was appearing to us that coal was formed by forests that were knocked over, rapidly buried, and the wood, before it could decay away, was converted to coal by groundwater, by pressure, by heat. Coal reserves all over the world could well be a reservoir from the pre-flood vegetation that was on the earth. Now, that was an interesting result. So we thought, let's look at something else that's made out of carbon, but is said to be even older than coal. And this other item is expensive. It's said to be 1 billion years old, and this was diamonds. The research, by the way, was getting expensive. But we were getting no government money, but just contributions. So this was carried out. We collected many different samples of diamond from South Africa and from Russia. And back to the laboratory we went. Sir, we now have some diamonds. Can you analyze these for carbon 14? And the people would just laugh at us, but they were kind of interested in this now because of the surprising results. Well, Jerry, in every sample of diamond we've looked at, there is carbon 14. And this research is continuing, and we are finding carbon 14 in coal, diamonds, rocks, minerals, fossils, dinosaur bones, every place we look. And all of this data is challenging the idea that these things are ancient. Not that we're going to convince the whole geology world that they're off by lots of zeros, but we've kind of knocked the ball into their court saying, what is going on here? There should not be carbon 14, and there it is.